Hello, let's now look at a couple of quick problems in the two sample test regime. A biologist maybe is interested in squirrel samples, squirrel weight of squirrels in two different places, and there are samples of 30 squirrels each in each of these places. The standard deviation is known, around 10 grams. The sample average ends up being 122.4 in one place, 127.6 in the other place, and you have to conclude whether or not the average weight is the same in the two locations, mu1 equals mu2 type hypothesis, right? So this is the two sample z test. So your test is going to be reject h naught if mod t is greater than c, where t equals x bar minus y bar, and that distribution is normal mu1 minus mu2, comma sigma 1 squared, which is 10 by 30, plus sigma 2 squared is also 10, 100, 10 squared by 30, 10 squared by 30, right? So both n1 and n2 are the same, so which is normal mu1 minus mu2 by 2 times 10 squared. 10 squared is 100 by 30 is 10 by 3 plus 10 by 3 is 20 by 3. Okay, so that's the calculation, 200 by 30, 20 by 3. Okay, so we know enough about this. So alpha is probability that mod t is greater than c given h naught, probability that rejecting it is given that it's true. So given this t is normal, h naught is mu1 equals mu2, it's 0. So you're going to divide by square root 20 by 3, and you know this guy has the distribution of mod z. Okay, so this becomes probability that mod z is greater than c by root 20 by 3, and mod z we know how it is. So alpha equals, this thing always becomes too big. Okay, alpha is so mod z greater than this is actually 2 times fz of minus c by square root 20 by 3, isn't it? So that implies c equals, you've got to put alpha by 2 here. Alpha we'll pick as 0.05 as usual, 0.025, so c is going to be minus square root 20 by 3 fc inverse of 0.025. Okay, so this is the standard calculation. We've done this before. The answer ends up being 5.06. That's the C. Okay, since mod 122.4 minus 127.6 equals what? It's 5.2, isn't it? 5.2 is greater than 5.06. You're going to reject h naught. Okay, 5.2, that's correct. Okay, and 5.06 is what you got. So just about borderline rejection of the null hypothesis. So you're going to conclude that the two averages are different, okay, and they're not the same. Okay, so hopefully you can see how this calculation goes. So here again data has been given, and we have to compare variances and say if they are equal or not. So this is important, right? I mean, quite often you have these instruments and you want to calibrate them with respect to each other. You want to see if both of them are the same in terms of variance. So this is an important calculation to do. Okay, so the first thing is to push this data into my Colab calculator, and that doesn't seem that easy in this case because I've got it into columns. I should have maybe put it in rows, but anyway, let me see if that works out. Give me something, we'll figure it out. Let's try it. So there is one data which I don't know if this is very clean. I'm sure there's a smarter way to do it, but let me just do it. Okay, so here is the data from the first instrument and the second instrument, and I'm going to now find the variance. I think that's what I need. So np dot variance. So I should just put the print here so that it just comes out. Np dot variance of xx1, comma, don't forget the DDOF, and then print np dot variance xx2, comma, DDOF equals 1. Okay, there you go. So this should give us the two variances which come out in a hugely different way. One is 24.41, the other is 146.28. Did I get that right? Does that make sense? I guess, yeah, there's some which are 15 and all that, so it's okay. Sort of makes sense. So Sx squared is 24.41. This guy has a variance of, if you want to call it Sx squared, so maybe I should write it more cleanly. Sx squared equals 24.41, and Sy squared is 146.29. Okay. Okay, this looks really off in some sense. Do they have the same variance? Once again, if you were to do Sx squared by Sy squared, it's going to be, you have to look at the left side, but this is n1 equals n2, so you can pick it any way you like. You should sort of get interesting answers. So if you pick alpha to be 0.05, I'm going to get, so you remember the picture for the F distribution, right? So it's got this distribution around 1. I'm going to go 1 minus CL here. This is the area. And this is alpha by 2. So 1 minus CL equals F of 7 comma 7 of 0.05 by 2. So from here one needs to compute this. So that's not too bad. st.f.ppf of 0.05 by 2 comma 7 comma 7. 0.2002, and then the other calculation is 24.41 divided by, okay, I think it's correct, 46.29. So this works out to 0.167. Okay, so let's keep that in mind. So this works out to 0.2, and since 24.41 by 146.29 equals 0.167, which is actually lesser than 0.2, I end up rejecting the null hypothesis. So it appears that they don't have the same variance with 0.05 significance level, so you should probably go in and look at the instruments, correct some of them if correct which one of the two could be wrong. Generally the one that gives you the higher variance is probably wrong. You go in there and tweak it a little bit and make sure it's okay. Okay, so that's the end of these kind of problems. So you may have problems where the data is actually given to you and you have to do these calculations and come up with the F test, etc. Okay, thank you very much.